Let's look at some real world problems here. So this is actually an equation that you can use anytime that an object is dropped and you know its initial height in feet. The equation for the height above the ground after some amount of time has passed, we'll call it t seconds, can be modeled by this function. H is equal to negative 16t squared plus h with a subscript of 0. And that 0 is a h naught. Okay, that's what you call it in your science class, h naught. So your initial height is that h naught of the object. And so, for example, the graph of negative 16t squared plus 200 would mean that our initial height was 200 feet. So for our problem number 7, we're going to start with a skydiver, and the skydiver is jumping out of an airplane that's flying at an altitude of 4,624 feet. So we want to write the equation in this format, but now we know what our initial height h naught is, so we want to plug that in. And so let's go ahead and write our equation that we will use for this problem. H is equal to negative 16t squared plus 4624. And that's the equation for the skydiver. This is neglecting any air friction that might occur. So it's not taking that into account. All right, we want to know if it's possible for the skydiver to wait 18 seconds before pulling the parachute cord, and then we want to explain our answer. So let's figure out what his height is after 18 seconds have elapsed so that we can decide if we think that he could wait that long to pull the parachute cord. So we want to find h when our time is 18. So h of 18. That's going to be negative 16, and then everywhere that we see our time t, we're going to say that it's 18 seconds. So we square that, and then plus 4624. Whenever we put that into our calculator, we are going to get a value of negative 560. Negative 560. So remember, we started at a positive 4624. And now we're at negative 560. So after 18 seconds, not only have we hit the ground at h equals 0, we have gone into a hole in the ground, if there was such a thing, that's 560 feet down. So that definitely means that this skydiver would not be able to wait 18 seconds before pulling the parachute because he would have already hit the ground and gone splat. We don't want that. So to summarize, no, he would have already hit the ground before 18 seconds because our h value isn't greater than 0. Remember, 0 is the ground. It's actually less than 0. So that means that he's already hit the ground before 18 seconds. All right, last problem here. For a science competition, students must design a container that prevents an egg from breaking when dropped from a height of 50 feet. Okay, so 50 feet is the key. That's going to be our starting height. So if we want to write the function that gives our height in feet after t seconds, we're going to use the exact same equation that we used for our skydiver. Remember that it's going to always be the same if we neglect air friction and just consider our acceleration due to gravity. And so in this case, our initial height is 50. So this is the equation that we will use for this problem. We want to know how long it takes the container to hit the ground. So remember, the ground is at a value of h is equal to 0. We're starting at h equals 50. We want to go to h equals 0. So that's all we're going to do. We're going to set h in this equation equal to 0 and then solve for the time t. So 0 is equal to negative 16t squared plus 50. I notice that I have something squared and I have a constant. So I can use square roots to solve this just like I did in the problems 4 through 6. So let's go ahead and get it in the right format for that. In order to do that, remember we wanted our squared term on the opposite side of our constant. So I'm going to go ahead and add 16t squared to both sides. So when I do that, this will cancel, and I'm going to write up on the next line here that I have 16t squared is equal to 50. Now, just like I did before, I want to go ahead and keep simplifying this until I get down as far as I can without doing square roots. So let's do this, and this is going to give me that t squared is equal to 3.125. I could have left it as 50 over 16, but remember, we're going to be talking time here, and fractions really don't mean anything to me when I'm talking about time. I'd rather see a decimal. So this is one of those cases where you can use decimals. I'm going to take the square root of t squared and also the square root of 3.125. I'm going to cancel that, and that will leave me with just a t. And so t is equal to, remember that we have to take into account positive and negative, at least for the moment, and rounding just a little bit, I'm going to get t is equal to plus or minus 1.77. Now think about that for a minute. The t is standing for time, and so this is saying either a positive 1.77 seconds, so a little less than 2 seconds, or a negative 1.77 seconds. Well, a negative value for t doesn't make sense for time unless you have a time machine, and then please share. But if you don't, then let's go ahead and say that the positive t is the only one that we can use because that's the only one that makes sense. Time can't be negative. Okay, so that means that our final answer is that t is equal to 1.77 positive seconds. So 1.77 seconds after we drop the container, it's going to hit the ground, and hopefully our egg will be intact. Part B of this problem says to find and interpret h of 1 minus h of 1.5. So it's asking us to plug in values of 1 and 1.5 for our t, and then subtract those and see how far we've moved between the seconds of 1 second and 1.5. So h, when our t value is 1, is equal to negative 16 times 1 squared plus 50. Remember our original equation, but now we're plugging in a t value of 1, and that's going to be equal to 34. H at a t value of 1.5 will be negative 16 times 1.5 squared, again, plus 50, and that gives me 14. So if I want h of 1 minus h of 1.5, that is simply going to be 34 minus 14. And that's going to give me 20. So this egg dropped 20 feet between 1 second and 1.5 seconds on its way to the ground, hitting the ground at 1.77 seconds.